8.3 is logarithmic functions. This is a function that's used when the variable you are looking for is in the exponent. Before we were doing this, we were looking for time, how long would it take for a house to reach so much money. We used the table function to estimate when that year would be. That was when the variable we were looking for was in the exponent. This is on be more algebraically how to solve an equation. So the first video is on be introduction to logs. Second video is on be finding the inverse. The next couple sections then are how some of the properties of the log function and solving the log function. So how do you find the inverse of a log function? That's on be answered in the second video. But first let's introduce log functions a little bit. Here we have log base b of y equals x. And that's exactly how it's read. Log base b, smaller value there, of y equals x. Some things you're going to have to be able to do is use that log function to rewrite some equations. Okay? And we rewrite the equation so then we can use that function to get the value or to simplify for the value. Okay? The important thing is being able to rewrite these. These two expressions are the same. We have the log form, log base b of y equals x, and that same equation can be written in exponential form, b to the x power equals y. Being able to rewrite this is going to be important. Picking out which pieces are going where is important. Here we have log base 4 of 16 equals 2. Notice the base here is the smaller value, the subscript. The base in the exponent is the normal base. The base is the big number there that's being multiplied multiple times. So if I'm rewriting this function as an exponential form, my base is on a stay 4. What it's equal to becomes the exponent. And I call it the whole number there. That 16 goes by itself on the right-hand side. And it's a true statement. 4 squared equals 16. So I wouldn't worry too much about what the values are. Worry about just moving things in the correct spots. Here we have m to the z power equals x. This time it's an exponent. Okay? If we were to write this as a log, we'd write it as log, or at least we started as log. M is the base, so that's not stay our base. Try and be careful when you write that. It's a subscript. Okay? It's a little smaller, it's down below. Kind of like an exponent, but down below instead of up high. What it's equal to becomes the whole number there. So we have log base m of x equals our exponent z. Okay, so rewriting those is going to be important, especially when we get to the solving part. Now, mental math is also going to be important. Okay? If you're asked to evaluate an expression, so here we have log base 3 of 81 equals x. If I ask you to evaluate or solve for that value of x, okay, first thing you should do is rewrite it as an exponent. Log base 3 of 81, so the base is 3, x becomes the exponent, equals 81. Like I said, you have to have mental math skills in this section, being able to think through, okay, what is that exponent going to be? 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81, so there's our x. X equals 4. Here we have log base 4 64 equals x. 4 to the x power equals 64. And again, you need to think through. 4 squared is 16, 4 cubed is 64. So x is 3. I'm not going to expect you to be able to do things like 4 to the 20th power. I'm going to expect you to manage 3 to the 4th power, 4 to the 3rd power. And also thinking through some fractions as well. Here we have 2 to the x power equals 108, or sorry, not 108, 1 over 8. And you have to think, okay, how can we make that 2 into an 1/8? Okay? You need to think the properties of the exponents. Okay? When an exponent is negative, that's when it goes below. So we have to think what negative exponent will give me 8. 2 squared is 4, 2 cubed is 8. Now, that gives us the 8. To bring it to the bottom, it's going to be negative 3. Because 2 to the negative 3rd power. You bring it to the bottom. Let's look at it. 2 to the negative 3 1 over 2 cubed, which gives us 1/8. Okay, so mental math is going to be important working through these problems. Okay. Now sometimes it's not going to be as easy. 5 to the x power equals 83. 5 squared is 25, 5 cubed is 125, so 83 doesn't fit in there. It's between a square and a cube, 2 and 3. This is when you're going to have to use the change of base. Now, some of the newer calculators have actually change of base on there. It function in the math menu. So if you hit math and scroll down, you should see change of base. If you don't have change of base, you might have to use this formula. And what it is, it's a division of the log functions. Everyone has the log button on their calculator, should be on your left-hand side. And a quick division problem, log of 83 divided by log of 5. Okay? We're dividing the log of the whole number by the log of the base, and that should give us, in this case, I have 2.746. Okay? So again, it's the log of the whole number here divided by the log of the base. Here we have log base 9 of 52. So same thing, if we look at 9 to the x power equals 52, 9 squared is 81, so right there it's between 0 and 1 and 2. So we need to get a better answer. So log of 52 divided by log of 9. Plugging that in, I have 1.798. Round the 3 decimal places, okay? And we would go on from there. Again, this is going to be important when we start solving these equations. Now the common log, this is some just important information about logs. The common log is actually the log that's on your calculator. It's just a log function. If you don't see a base, that's considered the common log. So if you just see, say, log of x, and what that log is, it's going to be log base 10. Okay, so if you don't see a base, your base is going to be 10. So if I ask you to rewrite log of 8 equals 3, well, I'm sorry, let's not say 3 there. I'm just making this all the time in my head. Let's just put it as a variable x. Well, if we don't see that exponent, okay, or sorry, if we don't see the base, okay, we know that base is going to be 10. So we could rewrite this as 10 to the x power equals 8. If you don't see the base is going to be 10. If you have the natural log is when the base is the natural value of e. Log base e of x. Now another way to write this is to write it as ln. That also is a function on your calculator. The natural log is a function on your calculator. So anytime you see log base e, you can write it as ln x, okay, or ln of x. Okay, so these are two ones that you're going to see a good amount. You have to become familiar with it because they are going to be important when we start solving again. Okay? So natural log and common log. And the last thing we're going to look at are two special log values. And again, they're not crazy special, but they're ones that you should become familiar with. They'll make your life a little easier when we start solving. If you have log base x of x, okay, that will always equal, when the base and the whole number are the same, that is always going to equal 1. And it should make sense. If I was to rewrite this in exponent form, x to the 1 power equals x. So that is true. So log base x of x, no matter what it is, log base 3 of 3, log base 20 of 20, it is going to equal 1. The other one is log base x of 1. Now think about what we would have here. If we were to rewrite this in exponent form, x to what exponent will equal 1? Well, the exponent of 0 always has it being 1. That will always equal 1. So log base x of 1 will always equal 0. Okay? So those are the special log values. We go over the common and the natural log and be able to rewrite a log as an exponent or an exponent as a log. The next video in 8.3 is on how to solve for the inverse functions.